In this lesson, we're going to solve and graph one-step inequalities. Example 1, how do I translate verbal phrases? So this isn't a complete list, but it does include most of the most common phrases that you would find for inequalities. So the first one we have here is less than. A couple of other ways you'll hear it is below or fewer than. We have greater than, and then we have more than or exceeds. The next one is less than or equal to. You might hear no more than, does not exceed. And another good one to add here would be maximum. And then we have greater than or equal to, at least, and minimum. So now let's translate the verbal phrase into an inequality. Number 1, Jennifer watches at most 3 hours of television a day. So at most. So let's let how much television Jennifer watches. We're going to represent that with an X. And at most, that means that she could watch less than 3 hours, but she could also watch equal to, but she cannot have more than 3. So X is less than or equal to 3. Jonas is sending a package to his brother in Afghanistan. It can weigh up to 20 pounds. So let's let the package be X and up to 20 pounds. So it can be 20 pounds, but it can also be less than 20 pounds, and it can be also equal to 20 pounds. Number 3, in order to win the game, Jack's score must exceed 125. So we have X is greater than, to exceed, we would have greater than 125. And the last one here, it says the speed limit is 60 miles per hour. Let S be the speed of the car driving within the limit. So we've got our speed of our car, and if the limit is 60 miles an hour, you can drive 60 miles an hour, and you can drive less than that, but you cannot drive more than 60 miles per hour. Example 2, how do I graph inequalities? So first of all, we have this X is equal to 5. If we ever plotted on a number line, X is equal to 5, we would just put a dot on the number 5. So this would be 4, 5, 6. So to express that we have X is equal to 5, we would have a solid dot on the number 5. Now, if we were to put on the graph X is less than or equal to 5, so we've got our 5. To show that it's equal to, again, we're going to have the solid dot. But then it's also less than or equal to 5. So we also have to show that it's going to be less than by shading to the left. And then X is greater than or equal to 5. Again, you're going to have on your 5 a solid dot to represent that it does equal 5, but then it's also everything that is greater than 5 as well. So it includes 5, 6, 7, 8, and so forth. Now, if we have X is less than 5, what that means is that it cannot include the 5. It's anything less than 5. So 4.999999 would be included in that, but not 5. So to show that it's not equal to that, but less than, we're going to circle, place a circle on the 5, and then we're going to shade everything that's going less than that as well. And then just greater than 5, again, we're not going to include the 5, but it's everything that's greater than 5, so we're going to shade to the right with an open dot. So example number 3, how do I write inequalities from the graph? So we're going to start with our X, and then since it's on the 4 and it's solid, that means that it is greater than or equal to 4. Number 2, we're going to start with our X, and notice how it's open. So that means it cannot include the negative 3, but it can be everything that is less than negative 3. Number 3, X is then, it's open, so it's just going to be greater than negative 2. And then our last one is X is less than or equal to 4. So it's going to be then less than or equal to 4 since it is a solid dot. Example 4, how do I solve one-step addition and subtraction inequalities? So we're going to solve these just like we did equations. We're going to start by drawing our line down, and we're isolating the variable. So to undo the minus 7, I would be adding 7 to each side. What you do to one side, you have to do to the other. And you're going to have x's less than or equal to then 4. So to graph that, we'd have our 4, and because it's less than or equal to, we're going to have a solid dot, and then we would be going to the left. This next one, again, we're going to solve it just like we have. I'm going to minus the 9 and minus the 9, and I'm going to have negative 10 is greater than x. Now, you have to be careful when your variable's not first. You have to be careful that because what we're graphing is x. So we could read this going backwards in terms of x. I could go x is less than negative 10. Now, I would like to rewrite these. So what I would do is I'm noticing that I'm going to put my x first, and I'm noticing that the smaller side is facing the variable. So when I rewrite it, that small side has to be facing the variable. And so now it makes it a lot easier for us to graph then. X is less than 10, so it's going to be open, and it's going to go to the left. So be careful on those. Number 3, it says the United States Postal Service will not mail any package that weighs over 70 pounds. You are mailing a package that weighs 51 pounds. So write an inequality to find the number of pounds you could add to the package. So our first package, or the package that we're weighing, is right now it's 51 pounds. Plus, we want to know how many more pounds we could add to it, but it will not ship it if it is over 70 pounds. So it has to be less than or equal to 70. And then when we would solve, we would subtract the 51 to both sides. And that means that you could have add a package to there that is 19 pounds or less. All right, for number 4, it's saying that the perimeter is greater than 21.8. So remember, finding the perimeter, you're adding up all the sides. So I'm going to take 7 plus 8.4 plus the x, and then it's saying that it's greater than 21.8. So remember, before we can solve or bring things from side to side, we do have to simplify. So I'm going to add the 7 and the 8.4, and I'll get 15.4 plus x is greater than 21.8. And then we're going to isolate the variable by subtracting 15.4 from both sides. So 21.8 minus 15.4. And you'll get then, so we minus 15.4. And we have x then is greater than 6.4. So what we know about that side, the missing side, is that it is going to be greater than 6.4 centimeters. All right, example number 5, how do I solve multiplication and division inequalities? Well, we're going to do these just like we do our equations. However, we have got to remember that when multiplying or dividing by a negative, all right, so it's when you're multiplying or dividing by a negative, you must reverse the inequality symbol. So we're going to be flipping them. Let me explain why. If you had 5, we know that 5 is less than 10. And if I were to then multiply both sides, let's just say I'm going to multiply by a negative 2. What I do to one side, I'd have to do to the other side. And now when I multiply, I would have negative 10, and I would have that negative 20. Now, because we multiply by that negative, remember, the more negative you are, the less value you have. And so notice how negative 20 is less than negative 10. And notice what happened here. Our inequality symbol flipped. So now let's go ahead and take a look here. Down below here, we're going to solve the inequality, then we'll graph the solution. So we have m divided by 4 is equal to 3, is less than 3. So we're going to multiply by 4 on both sides, and we're going to have m is less than 12. So again, we'll have 12, it's less than, so we're just going to have open, and then we're going to shade to the left. Now for our next one, notice that we're dividing by a negative. So we need to then multiply by a negative on both sides. And because we multiplied by a negative, we have to flip that inequality sign. So make sure that you flip that, and then we'd have negative 24. Because it's greater than or equal to, I'm going to have it solid, and it's going to go to the right. Number 3, Negative 3 is multiplying the x, so to undo that, we're going to divide by negative 3. What you do to one side, you have to do to the other. And again, I just divided by a negative, so we have to flip the inequality sign, and we have x is greater than or equal to negative 3. So again, I'm going to take the negative 3, and because it's greater than or equal to, I'm going to have solid, and I'm going to go to the right. Now, number 4, the 9 is multiplying, so again, we'll divide, and we're not flipping it because it is a positive. However, notice that the variable is coming second after the inequality sign. You would read this in terms of x is less than or equal to 2. I'm going to just rewrite this before I graph it, and because the little side is facing the variable, I'm going to flip my inequality sign around, and x is less than or equal to 2. So when you had an equal sign in between, it didn't matter which side your variable went on, but you do have to be careful when you are doing this with the inequalities. So I'm going to have shaded, and I will go to the left. All right, in our last example here, it says, you are in charge of purchasing helium balloons for a school carnival. You have been given $40 to buy the balloons, and the balloons cost $2 each. Write and solve the inequality that gives the possible numbers of B balloons you can buy. So if each one of our balloons costs $2 for every balloon, I have $40 now. I can spend all of the $40. But I don't have to spend all of the $40. I could also spend less than $40. So that would be a less than or equal to, and I'm going to divide by 2, and x is going to be less than or equal to 20. So how many balloons can you buy? You can buy 20 or less. So in this lesson, we took a look at how to write and solve one-step inequalities.